If gold is scattered in Earth's crust, how does it gather into rich veins and deposits? The answer is water, but not the kind you drink. Deep inside the Earth, superheated water rich in minerals acts like a golden highway, carrying dissolved gold through cracks and fractures. These hydrothermal fluids are responsible for some of the richest deposits ever discovered, and without them, gold might never have been accessible to humans. Hydrothermal fluids are hot waters that circulate deep underground, often near volcanic regions or fault zones. Heated by magma, these fluids can reach temperatures of hundreds of degrees Celsius and become saturated with dissolved minerals. Gold, normally insoluble, can actually dissolve under these extreme conditions when sulfur, chlorine, and other chemicals are present. The result is a moving solution of water and metal, flowing through Earth's cracks and fissures like an underground river of wealth. As these fluids move, they follow pathways created by fractures, faults, and zones of weakness in the crust. Think of it as plumbing on a planetary scale. The cracks in the Earth are the pipes, and the hydrothermal fluids are the carriers. Along the way, gold remains dissolved, invisible to the eye until conditions change, perhaps a drop in temperature, a shift in pressure, or a chemical reaction. At that moment, gold is forced out of solution and precipitates, lining the walls of fractures and forming veins that can be mined millions of years later. Some of the world's greatest gold regions were formed by hydrothermal activity. The Mother Lode in California, the veins of the Canadian Shield, and countless deposits in Nevada's Carlin Trend all owe their origin to these golden fluids. Even the famous Witwatersrand Basin of South Africa, which holds more than 40% of the world's mined gold, has a hydrothermal component in its story. Without this process, much of the gold we know today would never have concentrated into economic deposits. For prospectors, understanding hydrothermal systems is crucial. Fault zones, quartz veins, and areas of intense alteration, where rocks have been chemically changed by hot fluids, are the signatures of this process. When you find quartz with iron staining or veins cutting through host rock, you're seeing the fingerprints of hydrothermal fluids. These clues guide geologists and prospectors alike, pointing toward areas where gold may still be waiting. It helps to think of hydrothermal fluids as part of Earth's circulatory system. Just as blood moves nutrients through the body, these fluids move metals through the crust. Over millions of years, they concentrate trace amounts of gold into deposits large enough to change history. Every gold rush, every mine, every bar of bullion ultimately depends on this hidden system that worked long before humans arrived. But hydrothermal activity is only one part of the story. Gold is also reshaped and enriched at Earth's surface by weathering and groundwater, a process called supergene enrichment. In the next episode, we'll follow gold as it rises toward the surface and becomes even more concentrated, forming some of the richest deposits ever mined. This is part 7 of the story of gold, hydrothermal fluids, Earth's golden highway. Keep watching to see how gold's underground journey continues in part 8, supergene enrichment.